Hello and welcome. This is Roger Cattell, VP of Sales at Dundas Data Visualization. Excited to be here with you today as we introduce you to our latest release of our business intelligence tool, Dundas BI version 2. Joining me on the call today is Ariel Pohorilis, who's our lead solution architect, who will be walking us through a live demo of the software. And just to quickly go over the agenda of the webinar today, I thought I'd start by giving a brief overview of Dundas and our business intelligence tool. Then, as I said, Ariel will walk us through a live demo, and then we'll end with a quick discussion around where we see the product development heading in the months to come, and how you can further explore Dundas BI for yourself or get in touch with us. And then we'll close with some Q&A. Dundas has been providing software in the data visualization marketplace for over 20 years. From our head office in Toronto, Canada, we manage all facets of our business, from product development to fulfillment and customer training. We support two products in the marketplace today. Dundas Dashboard is a rich data visualization software with hundreds of users around the world. We also launched last year our Dundas Business Intelligence software, DBI. We'll be getting a more detailed look at that a little later when Ariel walks us through a demo. For those who might not be familiar with Dundas BI, let me provide a brief overview. Dundas BI is an end-to-end enterprise-ready BI solution with a strong focus on data presentation. Whether you're a consumer of content or a creator, you benefit from our tailored self-serve analytics and single experience on any device across all data sources. As a consumer of business intelligence content, you're able to further customize what you see and to drill down, collaborate, and share, and much more. If you need to create powerful, interactive, pixel-perfect dashboards, reports without having to worry how your data is structured, then you get on-the-fly data analytics. Our unified data layer allows you to work in the same way with your data, no matter where or how it is stored. Our powerful design functionality will enable you to explore and analyze your data and create your BI content on any device. Imagine you start work on your dashboard on your desktop, and then you go home and continue to develop using a tablet. And then in the morning on the train into work, you're using a smartphone. All this is done without having to install any additional applications or modules or being tied to your desktop. If you're a very technical data analyst and need to prepare data to be consumed by others, then you get your very own ETL designer. If you're a developer or integrator, then you'll benefit from the flexible platform, which allows you to customize, extend, and integrate to meet any business requirement. And then if you're an IT user concerned about security and version control and controlling the deployment, user management, etc., the application was developed with your requirements in mind, and you get this functionality out of the box. Why do customers choose Dundas? In a word, flexibility. Dundas is known for embedded BI. It's our ability to integrate with other software or to be customized through fully open APIs mean we don't restrict organizations in terms of what they can do with our software. Data can help organizations optimize their performance, and providing access to this data through a managed self-serve environment is the best and most economical way for companies to achieve this. Our BI software provides self-service tools and all the security and governance controls administrators expect. With years of experience in the data visualization space and a strong track record of listening to the voice of our customers, we work with some of the world's most innovative companies and help them to discover and exploit the strengths of their business enterprises. I'll pass things over to Ariel now, and he'll provide an overview of what's new and give us a demo of version 2. Ariel?
Thank you, Roger. I'm really excited to show you some of the great enhancements our R&D team was able to introduce so rapidly. Version 2 has over 100 new features. Those are mostly aligned across three major themes. First, new advanced data visualization options, allowing you to consume your data in more efficient ways. Next, building on top of the existing foundation for data analytics, Version 2 includes some new exciting options to analyze your data even further, with some advanced capabilities for predictive data modeling and data analysis. And finally, the ability to track and monitor your solution and end-user adoption to ensure successful implementation. Let's get started with those features and demos. First up, new visualizations. In our continuous effort to provide advanced new ways to visualize your data, we have now added new visualization controls for sunburst charts, also known as multi-level pie charts, pie gauges, bullet graphs, and data images. We've also added new animations on table visualizations that can help you easily reflect data changes across the entire set of table cells. Since most of those are custom ways for visualizing data, let's see some of those in a live demo to better understand the appropriate use cases. Here's an example for a real-time call center operations dashboard. It is designed to be displayed on a big screen TV on the walls of the different call centers operations room that we run. It is showing some of the key metrics of the call center, such as the inbound and outbound close rate percentages, the number of calls being handled, the abandon rate, the average speed of answers, and so on and so on. You can see that the different metrics on this dashboard are using different types of visualizations to highlight the metrics in the most efficient way. On the top right hand side, I'm showing percentages for the inbound and outbound close rates of my calls. You can see that I'm using those pie gauges to highlight those different data points. Now I could have just used a data label to just show the percentage, but using the visual it's actually easier for the user to quickly understand, first of all, if I'm going above or below my SLA, which is the red range band, and also to quickly understand what is the value without having to read a data point and process it in my mind. The pie gauge is simply a stripped down version of the pie charts using just a single pie slice. The next visualization is an exciting addition to many of our users, the sunburst chart, also known as the multi-level pie chart. This chart allows to view the data across multiple level hierarchies in a single view without having to drill up and down to see the data at the different levels. It is similar to a tree map visualization, but instead of using rectangles, it is using a radial layout to show the breakdown. In this example, you can see the breakdown of the smartphone operating system market share. The inner circle is showing the parent or top level of the hierarchy, and then the outer circle is showing the breakdown to the operating system versions. You can also easily interact with the chart using the right click or left click to focus on a specific slice. In this case, I can click on the iOS market share, and I can see the breakdown at the actual version of different iOS operating systems. So for example, I can see that iOS 8 represents 67% of the entire iOS operating system market share. I can also easily drill back up just by clicking on the most inner circle button of this multi-level pie chart or sunburst visualization. Here is another example for an interactive sunburst chart. In this example, it is a rotating sunburst. I'm not yet sure what would be the perfect use case for this interaction, but I wanted to use this example to show the flexibility of the visualizations and how Dallas BI developers can take it even one step further by applying their own custom interactions using our API and JavaScript. For example, here, I can switch and edit this view, and then I'll notice that on the top right hand side, I have a timer control added to this dashboard. The timer control can be easily added from the components menu at the top. Once I've added the timer control, I can just go in and select the properties menus of this timer control and control the timer interval for this control. So basically set how often I actually want to trigger an action on every tick of this timer. So right now, I'm going to set it to every 1 second. On the bottom, I have a timer interval action with my script. If I open that script, you can see in the script editor the logic that will allow me to control the rotation of this sunburst. So for example here, I'm actually controlling the angle of the sunburst every 1 second. Now one of the things you'll notice that we've added in version 2 is the ability to easily write those scripts using the autocomplete option. So for example, when I start writing my script, I can actually use the autocomplete option to see all the objects and methods I can easily apply to that type of visualization and that type of script. As mentioned earlier, Dallas BI version 2 now contains a new type of visualization we call data images. This control is used to show images in a dynamic fashion where the actual loaded image is bound to your changing data. It makes sense to use this control where you need the image to change every time you load a dashboard based on a dashboard context. An example, if a specific user loaded that dashboard, or a data point loaded based on the latest data retrieval. It also makes sense to use this control where your design needs to repeat itself, maybe even across multiple pages, so meaning that you want to use a report or a scorecard. In this example, I'm using a sales order report, and the data is being generated for every order number. As you can tell, my data image is used to show the image of the salesperson attached to that order. As I go in and change the filter for this report and change the actual order numbers, you'll be able to see that once the data updated, once I apply my new selection, it will actually go in and retrieve new images for a different salesperson. So for example here, you can now see a new image attached to each one of those order numbers I've just retrieved with my new data retrieval. The last functionality around the visualization I'd like to show today is in regards to a new data table animation. In this example, I'm monitoring the manufacturing site production line status. As you can see, that table data is updating every 5 seconds, and every time it updates, the table highlights the cells where the value actually changed, in this case, where the status codes of the different production line bays changed. This is a great option to help users quickly identify data changes, especially when they consistently need to monitor the same screen and there are a lot of values in the table visualization. Moving on to our second area of enhancement. All of those great visualizations that we offer today lean on our data engine that allows not only pulling your source data and integrate it together to show descriptive analytics for your current business situation, but also to create further data manipulation for advanced data analysis. On top of the existing options for predictive analytics, we now added some simple and advanced options to further create data analysis and predictive analytics models you need to have in order to be proactive. Many of those options rely within the applications and the ability to interact with the data, such as advanced filters and data selections, and some are around the data preparation layer, where you can now use new data transformation, including a new transformation, to use our scripts. Taking a closer look into predictive analytics and R in particular, it is important to understand that Danfoss BI native formula engine already gives you easy-to-use calculations. Now, with the R integration, you can take it one step further. If you are working in the capacity that requires advanced statistics, you probably know R, the popular open source statistical language that contains over 5,000 packages for common analytic processes. Using Danfoss BI and R together gives you the best of both worlds. You can now explore your data with ease in a drag and drop environment. You can seamlessly integrate into your models, scripts, and packages using interactive dashboards that allows you to easily slice your data across multiple dimensions, slicers, and change data levels across different aggregations and hierarchies. Finally, all of this can be used to create beautiful interactive presentations of your findings in seconds. Let's go back to Danfoss BI to see some of those new capabilities in action. First, I'd like to show you some of the options available in Danfoss BI for trending and forecasting. In this example, I'm looking at my orders by time and products. One of the new options we've added in version 2 is the ability to filter data across multiple hierarchy levels using just your own free text filter. So for example, in here, let's say I know there is a specific event throughout the year that could impact my different sales across different products. For example, the Tour de France is about to come, and I know that could impact my bike sales. I'm just going to type in the word bike under my product filters, and this will go in and filter all the possible products that are associated with the word bike under my product hierarchies. So for example, here, even though I have products across accessories, bikes, and clothing, I can expand a specific category like the accessories, and I'll notice that there are some subcategories in those categories that represent products which are related to my bikes. In this case, the bike racks, the bike stands, and I'm sure that under cleaners, there'll be more and more products related to bikes as well. So that's great. I can now filter information across different levels without having to go in and check each one of the products I actually want to look at, which are related to a certain topic. If I go back to all, I can still ask myself the question, how is this data going to behave and trend over time? What's going to happen in the future? For that, I can use the built-in formula functions of Danfoss BI. I'll use the Edit Copy for Analysis button on the top bar menu, which will basically allow me to create a copy of this dashboard in my own environment, what we call my project, and further analyze this chart to create my own data analysis. So for example, if I go in here and now decide to modify this chart, this is not going to impact some of the other users using the same dashboard. So in this case, I'm just going to open my data binding panel and maybe switch between the order dates and the products. I'm going to move my product into the slicers and the order dates into my rows. So now I'm viewing the information across different years. And let's say I want to now get a prediction how this data is going to behave in the future. I can right-click my bar and use the data tools And under the data tools, you'll see different options to further analyze data. For example, the ability to add a formula expression, which is exactly what I want to do here. So I'm going to use the add formula, and you'll see a new formula bar here at the top, maybe similar to the way you'll be designing expression in Excel. And now I can just type in any expression that comes to mind that makes sense in order to help me analyze this data. So for example, I can do things like summations, averages, which are common functionalities, but I can also do advanced functions like the trends and forecasting one that will allow me to predict how my data will behave in the future. You can see as I'm using the expression, it will allow me to use different types of forecasting algorithms. For example, I can use linear regressions, exponential, logarithmic, and power regressions to predict how this data will behave in the future. So in this case, I'm just going to go in, select my date, and just click on the measure I want to input into that trend and forecasting formula. I can even choose what type of output I want to use. I'm going to use a line chart to represent this new calculation, this new forecast into the future. And I'm just going to go in and apply it to my chart. So now you can see a new trend and forecast line showing me how this data is going to behave in the future. In this case, I'm showing data at the year level, so I can see the prediction all the way to 2016, which is exactly half of my data input, which is another variable I can use to input into my formula. I can definitely change those variables and provide different types of forecasting. Maybe I want to use a 4 years prediction forward. Maybe I want to use just 1 year and predict based on that. So that's great. Now I'm able to see how this is going to predict in the future. And I can even go back into my data binding and decide to move the products not only on the slicer, but actually onto my columns, and see that breakdown, that forecast across the different categories I have as well. So now I'll be able to see four predictions, one for each of the product categories I have. And again, I can go back in here and maybe filter on a certain set of products, and this will go in and now predict for that specific category how this will behave in the future. So this is an example for predictions I can make using the native built-in DandoSBI formula engine. In the case where you want to create additional or even very advanced data models for data analytics, such as multivariate regressions, outliers identifications, data segmentations by classifications, and so on, we now recommend using the built-in R language transformations, where you can leverage the power of R to create advanced calculations. In order to use the R transformations, you want to go into the DandoSBI Data Cube layer. DandoSBI Data Cube layer is the layer where you can prepare your data and create additional data transformations to better optimize the way the data is being laid out to the users, or just to simply provide to the user a self-service experience layer where the user can just drag and drop from a set of measures and dimensions to create his own data analysis on the fly. In this example, I've created a data cube model that allows me to leverage R to create a classification across different data points. In this example, my raw data is actually a data set, a very known data set, which contains the Fisher iris measurements for sepal and petal length and width of different type of irises. So what I'm doing here is I'm actually breaking down my data into raw data for prediction, which I'm actually going to put into my R engine, and then I'm also using data for validation, and I'm using that to actually process my results and display the information on my dashboard. So let's take a look at the R language transformation, which is a new data transformation, as mentioned, you can add into this data cube model. And what you'll be able to see here is the R script. If I go and edit the script, what you can see is that I'm actually using the R functions for using the k-means clustering algorithm. The k-means algorithm is basically an algorithm that allows you to get multiple variables and decide how many clusters you want to generate out of those variables using an algorithm that will randomize the location of the means of those different clusters, and then based on the distance from that mean will classify the different data points into that cluster. So in this case, I'm deciding to put into my algorithm 3 different clusters, basically telling R to use the k-means clustering functions to divide my data into 3 different data sets, 3 different clusters, 3 different groups of data. If I go into my data preview and look into the RA results of that transformation, you can see that it's actually generating 3 different transformations, 1, 2, and 3, and I'll see different random numbers across my different samples data sets. So I'm using that data, I'm joining it back with my data for validation, and now I can go into my dashboard and take a look at how this data looks like. So I'll go back in here, and what you'll see here is the data displayed, and I'm basically showing the sepal width against the petal length of different data points. Each one of those data points is a different measurement, is a different sample in my data set. And I'm going to use a top chart. As you can see, it's identical to the bottom one. I'm going to use a top chart to show what the actual clusters looks like, what the actual classification of those different samples into different flowers groups corresponds to. And then I'm going to use the bottom one to show you what the R engine provided with the k-means method. So I'm going to go into my top chart, and I'm just going to open my data binding panel and add into my columns the actual species the different data points correspond to, the different samples. So you can see here, it's actually distinguishedly showing you 3 different clusters on this chart. The top left-hand side, and then on the bottom right-hand side, you can see 2 different clusters that represent different species of the iris. On the bottom, I'm going to go again into my data binding panel, and on the columns, I'm going to plot my predicted cluster, the one that R generated for me. And you can see the results are very, very similar. This is cluster 1, cluster 2, and cluster 3. It's very similar to the actual clusters that are known to me once I go in and manually analyze the different species of the different samples. One thing to note though, the k-means algorithm is not totally deterministic. The beginning of the algorithm is actually randomized, so it may yield different results and won't always mean that you actually get the right clusters classification. Obviously, you need to understand a bit more about the algorithm and what you're trying to do to make sure you get the right data results. There are different algorithms that will help you understand how many clusters you should actually use in this data set, and that's what you should probably input into your k-means algorithm. In this case, on this sample data set, using 3 different clusters is not the always optimal number of clusters for this data set. So for example, if I actually go in here and refresh my data, you'll be able to see random results. The results are actually changing as I refresh my data, and in some cases you'll see that the results that our algorithm produce are actually not very much in line with the original clustering. So for example, here's a good case. I refresh my data multiple times, and in this run you can see that the k-means algorithm returned a distribution of clusters which not corresponds to the actual real-life distributions of these different species. So as you can see, R is very powerful. It gives you a lot of options to use advanced algorithms. As mentioned, in this case, it's for clustering. But you obviously need to make sure that you validate your data and you know how to use those different data models to properly predict and use those data analytics on your data sets. I'll move on to another example where I'm using what-if analysis to be able to understand how my data will behave according to different variables. In this case, I'm again using the formula engine of DandaSBI, but this time I'm using it in conjunction with different placeholders I can use as parameters, as variables I can input into my data and control how the data will actually behave in the future. So for example, in this case, I'm actually looking at the investment objective where I have different variables such as the yearly contribution, the expected growth, and the expected risk I'm willing to take in that specific investment. And you can tell the existing projections for the expected growth and the low and high ranges based on my calculations, based on the actual formula I've used for that specific chart. Now those variables I can now play and tweak with using either filter control that I can just type in the values in. For example, I can change my yearly contribution to 15,000 and see how will that impact my results. And I can also decide to play with the other variables. So for example, I can increase the risk I'm willing to take, maybe to a 20%. But with the increased risk, I'm also expecting a higher growth. So let's change that to a 35% and see how this data will behave with those new different types of variables. So this type of what-if analysis can again be modeled with my formula engine. It can also be modeled against other variables which are coming straight from my database, or again leveraging the R function, the R language transformation I just demonstrated, and put some variables into there to be able to basically control how the result will behave based on different variables. One more option I'd like to show in regards to the way users can now analyze and interact with data is around the top and bottom functionality. In version 2, you can now directly edit your metric sets to restrict your data retrieved to a specific amount of data points from the top and bottom of your data set. So instead of scrolling up and down to try and focus on your key data, you can now quickly and directly do so from the metric sets. For example, here, I can go back and edit the binding of this metric set. And what you'll be able to see is that if I edit that, there is a new top and bottom variables where I can put in the number of data points I want to retrieve for each. So in this case, I want to retrieve the top 2 data points and the bottom 3 data points for my different products. I've actually used the API as well to link those 2 different sliders controls that I have on my dashboard. And now I'm able directly from the sliders to change those values without even going back into the metric set and edit that. So for example, here, I can decide I want to show the top, or actually the bottom 4 worst products from my specific chart. So a very quick way to help me focus on the top and bottom, and the unique way as well to be able to visualize it together in the same chart without having to have a different chart for my top and bottom data results. I've also used here different states. In this case, my state is going above or below the median value to represent the colors or to quickly highlight the top and the bottom performing products. The last theme of innovation I'd like to cover today is the usage tracking and other admin optimization tools. Adoption is probably the single most important key performance indicator there is when it comes to BI tools. Studies indicate that less than 30% of BI tools are adopted by intended end users. Starting from version 2, we now give you the option to track the users and dashboard usage using our own built-in dashboard sample. We also built a dashboard that helps us track the load time performance, which is one of the biggest factors contributing to the likelihood of users adopting your solution. This, together with other admin tools, gives you additional insights into your overall deployment status. Here's a live demo showing how to use those tools internally. Here is the usage tracking dashboard we've built on top of the new table we have in our application database that collects information about the usage of the different dashboards. So every time a user logs into the dashboard application or to a certain report or scorecard, we actually track that, record that in the database, and then that can be used to display information. In this case, again, we built our own dashboards within Dandas BI to represent the actual statistics on top of that table. So you can see those informations against the date dimensions, so where that event actually happened, on the which dashboard it belongs to, what account was that in use, and you can see the default is actually showing it across all dashboards and all the accounts for the current month. So I can see, for example, for the current month, the number one used dashboard in terms of number of entries was a dashboard named the microsite, and there are 352 entries just in this month alone. And I can see the top users within this month is username Jeff, and in total, the total overviews for the entire dashboards was 907, and we had 491 different users entries to the dashboard. I can also see even statistics about the current usage. So right now there's 2 active sessions within my environment, and I can also analyze it over time. So the usage over time at the day level, and I can compare that view time to the number of entries. Those two should pretty much correlate. And if I switch between the day to the week view, I can see that data also being aggregated to the week view, and I can see that week 25 was the most important week in terms of usage of my dashboards, and since then I'm trending down a little bit. Maybe something changed and I'm now using my dashboard less. Maybe there was a special event in that week that triggered me to use dashboards a bit more, or maybe my dashboard are not as relevant as they used to be and I need to now modify them. Down in the bottom and in the center of the dashboard, you can see more statistics around the actual usage, broken down at the dashboard level and user level. You can switch between a table view that is sorted by number of entries, so focusing on the top entries at the project and then allowing you to maybe break it down to a specific dashboard, or maybe being even able to switch this to a scatter plot showing you the distribution where each data point is a dashboard. You can actually click on it and filter the rest of your dashboard for that specific data point. And what you'll be able to see here, for example, is that there is a dashboard here that has 300 minutes of average view time, which is quite a lot, but only 4 entries. This is actually a dashboard called the company timeline. It may be just a dashboard someone left open, or maybe there is something very interesting on this dashboard that maybe triggers additional analysis. Maybe we should actually promote this dashboard and provide to other users, or even think of other ways to better design it to help the user quickly understand data points without having to spend so much time on it. On the bottom, there's the activity report that allows me to view the information at the project, and then dashboard, date, accounts, and other statistics about that different users' activity. But what's important to also mention is the top right-hand side, which is the self-service user activity area. So this area actually tracks the number of dashboards that users create on their own in their own project. So this is the number of dashboards they've created on their own. I'm actually the leader of the creators in this category, so I've created 34 personal dashboards for my own analysis, for my own data discovery, and then I can choose those to share those dashboards with other users. I can keep them for myself, but you can see I'm very active in the environment, not only as a consumer of existing dashboards and reports, but also as a producers or almost kind of a user that analyzes data on its own without having to depend on other users. So that is the user tracking dashboard, and this is the sister dashboard, the performance tracking dashboard. And this dashboard really gives you the ability to analyze which one of your dashboard takes a long time to load, which is again a key factor when you look at the adoption of the dashboard. Users don't like to wait a lot of time for the dashboards to be loaded. You can actually set this up in your environment and even set up email notifications to send you emails whenever one of your dashboards takes longer than a certain number of seconds to load. For example, in this case, we've set the state to be less than 5 seconds. That means that every data point, every metric set that I have on my dashboard, a query that takes more than 5 seconds, I'm going to highlight in red. In this case, it's this specific metric set. And I've also enabled myself to be able to click on that metric set and go in and dive into a detailed view of that metric set. So I can see in total, that's the sales over time metric sets. It was loaded 3 times. And the maximum load time was 7 seconds, while the average is 3 seconds. At the bottom, I have some information about the parameters used when that event occurred. So I can further analyze that and see maybe that a specific parameter combinations takes a long time to return the results for that query. On the top left-hand side, I can see again statistics around the worst metric set, which is exactly that one I just looked at, the sales over time. And I can see also the average load time for all the metric sets in my system, which is currently 0.0 seconds. It's very, very low. It's actually past the first decimal place for that specific number. And down below, I can see the breakdown for all those different metric sets. And as I scroll down, I can see that information. Again, right now, this is filtered on the last 30 days. I can obviously increase that time range and see additional performance of those different metric sets in the past. Notice that on both of those dashboards, the usage tracking and the performance tracking, you have help overlay information that gives you some information around the way this dashboard is built, what kind of data is available in those metric sets, and how you can further analyze that or interact with it. Now, the last option I'd like to show you around the new admin views that we've created is the system health views. So if you open the system health menu on the admin panel and you click on the jobs, what you'll be able to see here is a new interface that allows you to focus on the different jobs that you have in the system. You can also filter by different parameters like the type of job and the job status. You can see which one is currently running or idle. And then you can see at the bottom here the report for that specific selection. So right now you can see there's a few projects here, a few jobs here where I'm either building a data warehouse or creating a data cube in memory. And you can see all those jobs last runtime, and if that result was successful, you can even drill down from here in further into that specific report and view. So for example here, if I want to drill down further on this specific job to build my cube in memory, I can just click on the result for it, and this will show me the job history for that specific job. I can disable it from here. I can also refresh it right now. I can also just take a look at the last 3 jobs that I had in that last 3 times this job was executed, and maybe even focus on one of those executions. So I can click on the results set here, and this will again show me a detailed breakdown of that specific job, showing me the processing and the actual stages and the actual values associated with each one of those stages. So this is again very helpful information when I want to build the data cubes in memory or in the data warehouse, or just monitor and track any other jobs such as the email notifications that I'm sending to my different users. This admin system health options together with the user tracking, performance tracking, really allows you to now control and govern your entire deployment in a way that will help you optimize it and make sure that it's being used, as well as to the way you've designed it to be used, so it's actually performing for the different users, and make sure that it's always healthy and up and running as expected. So a lot of options to help you, the administrator or the control of the environment, the developer of the environment, to be able to easily deploy that solution in a way that is successful for your users. So this concludes the demo portion of this webinar. Obviously, we can't demo in detail all the new options of version 2 during this session, but I hope you are excited as we are about the new additions of version 2 and are looking forward to get your feedback and see what you can build with it. I'll pass it back to Roger now to talk about what's next.
I'd like to give a high-level overview of what the next few months look like from our perspective. There are 4 main areas of focus that we have here at Dundas. We will continue to focus on being a leader in the data visualization space. This means more visualization enhancements, easier access to source data for reporting and analysis, and a simpler way to customize the information that you see on the dashboards. Turning data into actionable information means providing more data analysis features. The goal of business intelligence is to improve corporate performance. So the more options to better manipulate and prepare the data, the better. We're also going to continue to improve our story around embedded BI, giving users more seamless access to the numbers that matter. And most importantly, we'll keep on listening to our customers. For those attending the webinar today, there are 3 available next steps. For the consumer of data, for the pure business user, I would recommend contacting one of our sales reps or solution architects for a live demo of the product. Best way to reach out to us is by going to www.dundas.com or sending an email directly to sales@dundas.com. For the more technical user, there's a free online trial available, and again, you can find details of that on our site. And for those with more of an interest in development, I'd recommend the full download of our product available for the next 45 days to give you a real opportunity to explore all the functionality that we've highlighted here today. Thank you for attending the webinar today. We're about to open up the floor to questions. You'll see the opportunity to input a question on the right-hand side of your screen. Please do so now, and we'll endeavor to answer as many of these questions we can in the time remaining. Thank you. Let's take our first question.